అయితే మరి మీరైతే ఫస్ట్ పంపించండి, తర్వాత మేము ఈరోజు 4 o'clock కల్లా ఇమ్మంటున్నాము. చెప్పిందే మార్నింగ్ కూడా అది 12 o'clock పైకి వచ్చి చెప్తుంది. నేను నాగలక్ష్మి మేడం తీసుకున్నాను.
ఏంటి ప్రింటా?
అప్పట్లో లాస్ట్ ఇయర్ ఎందుకు మరి ఇప్పుడు ఎంఎస్సీ అంటే అప్పట్లో
Yes, is my voice audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We have to take the revision. It is the module 2. So how many topics are there in module 2? First topic is eigenvalues and eigenvectors.
Yes, Samantha.
So how to, yes, listen all of you. So okay, so first topic is eigenvalues and eigenvectors, isn't it? And
Yes,
what is
ma'am.
our next topic? The next
Diagonalization
topic
of a matrix.
Okay, diagonalization of a matrix. Of a matrix. And what is our next topic?
Cayley-Hamilton theorem.
Linearly
Hamilton
dependent
theorem.
and independent.
Yeah, yes, ma'am.
Linearly dependent and independent, isn't it? And the last topic is
Cayley-Hamilton theorem.
Hamilton theorem. Okay, so how to find eigenvalues? First we need to find the eigenvalues now. So how to find the eigenvalues?
By characteristic equation.
So by using the characteristic equation, we can find the eigenvalues. What is the characteristic equation? That is det of
The det of a minus lambda I is equal to 0.
If it is 2 by 2 matrix, so what is the shortcut method for this? So
Lambda square minus
minus
lambda
lambda
into trace of a plus det a is equal to 0.
is
ma'am.
that a equal to 0. If it is 3 by 3 matrix, lambda cube minus lambda
Trace
square
of a
trace a plus lambda into
sum of product
Sum of the non-diagonal elements.
diagonal elements.
product.
Some of the minors of diagonal elements.
Okay, some of the minors of non-diagonal elements
Minus
minus
det of the
sum of minors of or product
of non-diagonal elements.
non-diagonal elements.
Minus det a is equal to 0.
Diagonal elements. So this total one is corresponding to lambda only. Okay. So minus det a
Minus det a is equal
okay,
to
so
0.
this is for eigenvalues. Okay, so we have to do det by using calculator, and also we can find the characteristic equation by using this formula. After that we can find the eigenvalues or roots. Okay, so roots for this characteristic equation by using calculator, right? So now coming to the eigenvectors. How to find the eigenvectors? Eigenvectors. So what is the formula for eigenvectors? We have formula that is a minus lambda I into
X is equal to 0.
0. Okay. So now coming to the diagonalization. So diagonalization formula is
D equal to P inverse AP.
P inverse AP. So what about P?
P is
Model
model matrix, ma'am.
X1,
Model
X2,
matrix.
Model matrix.
So that is nothing but P equal to
X1, X2, X3.
X2, X3. So what about X1, X2, X3? So these are the
Eigenvectors.
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 eigenvectors. Okay. So the
Ma'am.
roots of the eigenvalues
Ma'am,
are
column. X1, X2 should be written in column.
yes, columns. These three columns are nothing but eigenvectors. Okay, so these are the eigenvalues. Lambda 1, if it is 3 by 3, no, you will get lambda 1, lambda 2, lambda 3. Yes?
అక్కడ సమ్ ఆఫ్ నాన్ డయాగోనల్ ఎలిమెంట్స్ మైనర్స్ ఆఫ్ నాన్ డయాగోనల్ ఎలిమెంట్స్ అది రాదు మేడం అక్కడ.
ఏదిరా?
అది సమ్ ఆఫ్ ద ప్రొడక్ట్ ఆఫ్ డయాగోనల్ ఎలిమెంట్స్ మైనస్ సమ్ ఆఫ్ ద మైనర్స్ ఆఫ్ నాన్ డయాగోనల్ ఎలిమెంట్స్ రాదు మేడం అక్కడ.
సమ్ ఆఫ్ ది ప్రోడక్ట్ ఆఫ్ ది డయాగోనల్ ఎలిమెంట్స్.
ఓన్లీ అది ఒకటే
మైనర్స్ రాస్తే అవసరం లేదు.
వస్తుంది.
ఓకేనా, మైనర్స్ రాస్తే ఇవన్నీ అవసరం లేదు. మైనర్స్ రాయకపోతే కనుక సమ్ ఆఫ్ ది ప్రోడక్ట్ ఆఫ్ ది డయాగోనల్ ఎలిమెంట్స్ మైనస్ సమ్ ఆఫ్ ది ప్రోడక్ట్ ఆఫ్ ది నాన్ డయాగోనల్ ఎలిమెంట్స్.
ఓకే.
So this is now coming to the diagonalization of a matrix. The diagonalization of a matrix formula is P equal to P inverse AP, where P equal to model matrix. The model matrix is denoted with like this. Okay, so P equal to x1, x2, x3, where x1, x2, x3 are eigenvectors. Okay, so how to find? So indulo inko question kuda untundi kada. What is that question? So we have to find the powers also. Okay, so how to find the powers? If you want to find a power 4, no, so what is the formula?
P into d power n P inverse.
A power 4. For a power 4, P d
P
power
d
4,
power 4 P inverse.
P inverse. Okay, so D is nothing but what is D? If it is 3 by 3 matrix, no, so D is nothing but D equal to lambda 1, 0, 0 eigenvalues of the
Lambda
diagonal
2, 0, 0, lambda 3.
lambda 3. Okay, so this is diagonalization of a matrix. Now coming to the linearly dependent and independent. Linearly dependent and linearly independent. So how to find if it is 3 by 3 matrix? If it is 3 by 3 matrix, then how to find the linearly dependent and independent? Anyone?
If data equal to 0,
If data is equal to 0,
Independent.
huh?
Linearly dependent.
Dependent.
Linearly
Linearly
dependent.
dependent. Don't forget. Okay, ఏదో ఒకటే గుర్తుపెట్టుకోమని చెప్పాను. So here we have two methods, right? So if data equal to 0, then that is linearly dependent. If data is not equal to 0, then that is linearly
Independent.
okay. So if it is not a square matrix, or if it is square matrix, the matrix will be in the form of 4 by 4. And if it is not a square matrix, in that case, how to
If
do this
r
matrix?
greater than n, it is linearly
So we
dependent.
have to write, first of all, mainly, so we have to form the matrix by using vectors. Okay, first eigenvector. So question will be in the form of like this, no? So this is our first eigenvector, right? So we have to write here like column wise. Okay, don't forget this one. Okay, so x1, x2, x3. So from that you can form the matrix. After that we have to convert the given matrix into
Echelon form.
echelon form. Okay, in the echelon form, so what is the formula? What
R
is
greater than n,
if R is greater than n?
linearly dependent.
Otherwise, if R equal to n, R greater than n, less than n?
Less than n, ma'am.
Yes, choose చెప్పండి.
Less than n, ma'am.
Less than n, ma'am.
If R is less than n, then that
Then
is
linearly dependent.
so. Otherwise,
Linearly independent. R equal to n.
if R equal to n, that is linearly independent. Okay, so this is based on linearly dependent and independent. So now coming to the next question. So next method. So what is our next method? Cayley-Hamilton theorem. Okay, so how to do the Cayley-Hamilton theorem? So first of all, we need we need the statement So what is the statement of Cayley-Hamilton theorem?
Every square matrix
Every square matrix satisfies its own
satisfies
characteristic
its own
equation.
characteristic equation.
Every square matrix satisfies
Its
Its
own
own
characteristic
equation.
equation.
its own characteristic equation. Okay, so first of all, we need to find the characteristic equation. Okay, so if, by using the formula, that is a det of a minus lambda is equal to 0. So if the characteristic equation is a lambda cube minus some 6 lambda square plus 11 lambda minus some 6 equal to 0. Okay, so then according to our characteristic equation, instead of lambda, we have to write
A cube.
a cube
Yeah.
minus 6a
6.
square plus 11a. For the constant, we have to put I here. Okay, so that is our method. So here, so how the questions will be coded? Like verification, they will give the question like verification, and the next question is inverse and powers. Okay, so verification means we have to prove that this total equation will be equal to 0. So if it is 3 by 3 matrix, then the matrix will be like 0, 0, 0, 0, 0, 0, null matrix. You will get null matrix. That is nothing but 0. So that is our verification. So how to find A inverse? For A inverse, we have to multiply with the A inverse of both sides. Okay, both sides. For A power 4, already here we have A cube, no? So for that, we need to multiply with A on both sides. Then you will get A power 4. Okay. So what is the formula for x power m and x power n?
X power m plus
For
n.
impulsion.
So x power m all power n is?
X power mn.
That's it. So this is our module 2. So now coming to the question bank. So first of all of you do the eigenvalues, eigenvectors problems. Where is the question bank? So is it visible, Amma?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So coming to the module 2. So this is our module 2, right? Okay.
Ma'am, I have a doubt in part B, 15th question, ma'am.
Just wait. I will check. Just wait. This is part B, na?
Yes, ma'am.
So
15th
this is our
question.
15th question, right?
So after finding out the eigenvalues and eigenvectors, to find the inverse, would I diagonalize the matrix and then use A power n is equals to P into D power n into P inverse? That formula. Would I use that?
Find the eigenvalues and eigenvectors of the matrix and its inverse. Okay, you can use any method.
I can use Cayley-Hamilton theorem also.
You can use, because they have not mentioned here, no? Can you tell me what are the eigenvalues for this particular matrix?
I didn't do it, ma'am.
Tell me, no? That is upper triangular matrix, right?
Upper triangular matrix.
2, 3.
1, 2, 3. So this is upper triangular matrix, no? So that's why the diagonal elements are the eigenvalues, right? So here the eigenvalues are these, right? So the eigenvalues are here. isn't it? These are the eigenvalues. Okay.
Yes, ma'am.
Upper triangular matrix or in a lower triangular matrix, the diagonal elements are the eigenvalues. No need to do. Directly you can say the eigenvalues. Okay. 1 minute. So now coming to the
So, ma'am, for inverse, can I use Gauss-Jordan method also?
no. Because you are in module 2, no?
Okay, ma'am.
Just wait. My laptop is somewhat slow, that's why. Shoot. Okay. Just wait up. Okay. So our first question is Cayley-Hamilton theorem. So if you want to find the Cayley-Hamilton theorem in matrix form, no, after getting a plus, if the answer is, what is the answer for first question? All of you done that question or not? Yes,
Yes, ma'am. We did it.
we have done. Huh? So what is the question?
16a minus 20i.
Just wait a minute. Okay. So do you have question bank now? Is it with you?
Yes, ma'am.
Okay. Just open the question bank. So tell me what is the question? So what is our first question? Verify Cayley-Hamilton theorem for 1 to 2 2, isn't it? Antena?
Yes, ma'am.
So the and evaluate something, that is 2a power 4 minus 5a cube minus 7a minus 6 equal to how much? Okay. So how to calculate this one? By using Cayley-Hamilton theorem. So before that you should verify.
Minus 6i, ma'am.
So minus 6, yes, minus 6i. So how to verify this? So I think all of you know that by Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation. So from that you can find the characteristic equation, right? So the characteristic equation is some det of a minus lambda I equal to 0. So what is the characteristic equation here? That is lambda square minus
3 lambda.
3 lambda. What is the det? 2.
Minus 2 equal to 0.
2 minus 4 minus 2 equal to 0. Okay, so this is our characteristic equation. So by Cayley-Hamilton theorem, what is the formula? So what is our statement? You need to write the statement, that is every square matrix satisfies its own characteristic equation. So from that you will get a cube minus 3a minus 2i. So you have to prove that that will be equal to this one. Okay, so prove this one. Okay. So you have to prove this one. So a square, not a cube. A square minus 3a minus 2i equal to, you have to prove that will be equal to 0. So after that, evaluate this one. Okay, so from the question or from the equation, So a square minus 3a, that is minus 2i equal to 0. So from that you can write a square equal to 3a plus 2i, isn't it? Antena?
Yes, ma'am.
So what about a cube and a power 4? So then substitute a power 4 highest power here. Then after that substitute a cube value, then a value. After simplification, you will get what is the answer here? What is the answer, Amma? Have you done this problem or not?
Yes, ma'am.
6a plus 8i.
6a plus 8i. So this is the required polynomial, right? So if you want to find the matrix, no, just you can substitute the matrix here, A. Okay. So that is 1, 2, 2, 2 plus 8 into what is I? 1, 0?
0, 0, 1.
0, 1. So if you find this value, no, you will get the required matrix. Okay. So this is the polynomial matrix and this is the polynomial, required polynomial. Okay. Okay. So what is our second question?
Using Cayley-Hamilton theorem to find a cube and a inverse 3 and if a equals to 2, 4, 1.
Is my screen visible now?
Yes, ma'am.
Yes, ma'am.
Not this one. Okay. So what is our second question? Have you done this problem, Mama?
Yes,
Use
ma'am.
Cayley-Hamilton theorem. Is the question paper is question bank is visible?
Yes, ma'am.
Okay. So use Cayley-Hamilton theorem. Find a cube minus a power minus 3. A cube minus a power minus 3 if a equal to 2 by 2 matrix, that is 2, 4, 2, 4 minus 1, 1. Okay. Okay, ma. So how can you find that? Okay. Yes, anyone? So by using Cayley-Hamilton theorem, you can find a cube and a power minus 3. Shall we do this problem?
Yes,
చేద్దామా
ma'am.
problem చేద్దామా? మీరు చేసేస్తారా? చేద్దాం. ఓకేనా?
Completed, ma'am.
Completed, ma'am.
Okay. So ఎలా చేశారు? How you have done this problem?
First verified Cayley-Hamilton theorem, ma'am.
Yeah, no need to verify, no?
Okay. Next we got an equation
yes.
a square minus 3a minus 2i.
That is what is the equation?
A square minus 3a minus 2i.
A square
Minus 3a minus 2i.
minus 2i equal to 0. So this is our equation. So how to find a cube?
Multiply a
With a on both sides. Then multiply with a on both sides, then you will get a cube minus 3a minus 2 into a equal to 0. So from that you can write a cube equal to 3a square plus 2a. Okay. So what is the answer, Amma? Answer.
28, 44, 11, 17.
11, 17. Okay. So then how to find a cube? A power minus 3, negative powers.
Multiply with a power minus 3.
Okay, if you multiply with a power minus 3 on both sides, no, then you will get So this is a power minus 3 into a square minus 3a minus 2i equal to 0. Okay, so what is the answer for this?
Half a power minus 1 minus 3a power minus 2.
So this is half. So a power minus 3 equal to 1 by
Half.
2 into
a power minus 1 minus 3a power minus 2.
3a power
Minus
minus
2.
2. But what about a power minus 2 value?
We can find it now, ma'am.
So before that, you have to multiply with a inverse on both sides. So you have to do like this, then only it will be easy. I will do. Okay. Just wait. So what is the question? So what is the equation? A square
minus
1 minute. A square
minus 3a
minus 3a minus 2i
minus 2i equal to 0. Okay, so first of all, multiply with a inverse on both sides, then you will get a square minus 3a minus 2i equal to 0. So this is a inverse equal to ఏమవుతుంది అప్పుడు సింప్లిఫై చేసి చెప్పండి ఫాస్ట్. a inverse equal to
minus a
minus a
plus 3i
plus 3
i plus 2a inverse. 2a inverse.
inverse.
a inverse equal to
1
total
by 2.
total a inverse equal to, tell me.
Half.
Okay, so otherwise if you want to do, just wait up. You want to simplify this one, right? So this is a power minus 1 plus 2. Okay, so then you will get a power 1. Okay, so next one is a is there. So a power minus 1 plus 1. So that is a power 0. A power 0 means you will get I. Okay, so that means a into a inverse is I, and I into a inverse is a inverse. Okay, so this is a minus this is I minus 2 into I into a inverse is a inverse. Okay, that will be equal to 0. So minus 2 a inverse equal to, so this is minus a plus 3i. Okay, so a inverse equal to 1 by 2 into a minus 3i, isn't it? Antena?
Yes, ma'am.
So then multiply with a inverse again, a inverse on both sides. Otherwise you have to multiply this one with a power minus 2 on both sides. Okay. Then multiply with a inverse on both sides. No, what you will get? A power minus 2 equal to one by 2 into simple, no? So it is a and this is here we have a, and here we have a power minus 2. Then 1 minus 2, that will be a inverse minus 3 into, multiply with a inverse on both sides.
Madam, a into a inverse.
Madam, I వస్తుంది కదా madam.
Okay, a into a inverse is I. This is a inverse. Antena?
Yes, ma'am.
So that is 1 by 2 into, this is I minus 3a inverse. Okay, so this is a power 2 value. So already we have find, no, a power 3, a power minus 3. So that is a power minus 3 is 1 by 2 into a inverse minus 3 a power minus 2, isn't it? Otherwise you have to multiply this one with a inverse. on both sides. Then you will get a power minus 3, that is equal to 1 by 2 into a inverse minus 3a power minus 2. Okay, so what is the value of a power minus 2? A power minus 2 is this one. Okay, so you have to substitute this one here. So that is a power minus 3 equal to 1 by 2 into a inverse minus 3 into what is a power minus 2? That is also 1 by 2 into I minus 3a inverse. Okay, I minus 3a inverse, isn't it? So after simplification, we'll get this is 1 by 2 into a inverse minus 3i by 2 minus 9a inverse by 2. Inka simplify cheyochu kada. So after simplification, this is 1 by 4. So 1 by 4 equal to minus 3i plus this is 11a inverse. Antena? A power minus 3 equal to. So first of all, you need to calculate a inverse by using this one. Okay, then substitute a inverse value here. And what about I? So this is 2 by 2 matrix. Huh?
Yes,
Is
ma'am.
this 2 by 2 matrix? Then there is 1 0 0 1. So what is the a inverse, amma? Anyone? What is
Minus
a
1
inverse?
by 2.
Yes, minus
1 by 2.
1 by 2.
2.
2
1 by 2.
minus 1. Okay. So after simplification, you will get chesara. What is a power minus 3 value? Simplify this entire one. Then you will get otherwise 1 by 4 you can keep in the outside. So this is minus 17 by 2. This is 22. This is 11 by 2. And this is minus 14. Okay. So once check whether it is correct or not. Okay. Okay, ma? Is it clear, all of you?
Yeah, ma'am, correct.
Correct.
Yeah, ma'am, correct వచ్చింది కానీ కొంచెం సింపుల్ ప్రాసెస్.
ఎలా అయినా చేసుకోవచ్చు, మన ఇష్టం. డైరెక్ట్ చేసినా వచ్చేస్తుంది. బట్ డైరెక్ట్ క్యాలిక్యులేటర్ లో చేసే కంటే ఇలా చేస్తే బెటర్ కదా. ఓకే, బట్ యూ హ్యావ్ టు చెక్ విత్ క్యాలిక్యులేటర్. ఓకే.
Okay, ma'am.
Next question is also same, no? State the Cayley-Hamilton theorem and find the eigenvalues of a square matrix. Eigenvalues of squares and the reciprocal of A and means find the eigenvalues of A square and A inverse. Okay. So ela chestam by using Cayley-Hamilton theorem. We can first just you need to state the Cayley-Hamilton theorem. Just you need to write the statement. After that is different question. Okay. State the Cayley-Hamilton theorem means here you need to write the statement of the Cayley-Hamilton theorem. After that, find the eigenvalues and eigenvectors. Okay. Find the eigenvalues. Find the eigenvalues of squares and reciprocals of A. So that means the meaning of that one is find the eigenvalues of A square and A inverse. So what are the eigenvalues for this particular matrix? Anyone?
2 3 5.
3 2 5.
2 3 5.
Because the diagonal elements are the eigenvalues, isn't it? Antena?
Yes, ma'am.
Because that is upper triangular matrix.
Yes, ma'am.
Upper triangular matrix eigenvalues are diagonal elements. Okay, so the diagonal elements are here 3 to 5. So that's why the eigenvalues are 3 to 5. Okay, so eigenvalues are 3 to 5. And what about the eigenvalues for A square?
3 square,
4
2
9
square, 5
25.
square.
3 square, 2 square, 5 square. Okay, so what about the eigenvalues for A inverse?
1 by 2, 1 by 3, 1 by 5.
Very good. 3 inverse, 2 inverse, 5 inverse. That is nothing but 1 by 3, 1 by 2,
1 by 5.
1 by 5. Okay, very good. So here also same. Fourth question. If A equal to 1 2 minus 3 0 3 2 0 0 2. then find the eigenvalues of this particular matrix. So before that, what are the eigenvalues of this particular matrix? Yes?
1, 3, 2.
1, 3, 2. So the diagonal elements are the eigenvalues. Okay, so because here also we have upper triangular matrix is there. So for the upper triangular matrix, the eigenvalues are here, the diagonal elements. Okay, so how to find this? Anyone? So what about the eigenvalues for AQ? So eigenvalues of A are 1, 3, 2.
Cube, 3 cube.
1, 3, 2. Okay. So what about the eigenvalues of AQ?
1 cube,
1
3
cube,
cube.
3 cube, 2 cube. So what about the eigenvalues of A square? 1 square, 3
1
square,
square, 3 square,
2 square. So eigenvalues of A is this one. So what about the eigenvalues of identity matrix? Anyone? 1, 0, 0, 0, 1, 0, 0, 0, 1. Because here we have 3 by 3 matrix, right? So what about the eigenvalues of identity
1, 1,
matrix?
1.
1, 1. So the diagonal elements are the eigenvalues. So all the eigenvalues you have to substitute here, then simplify, you will get the required eigenvalues, isn't it?
Yes,
Enta
ma'am.
answer? Simplify chesara?
434, 110.
Very good. 4, 34,
34.
1.
110.
110.
So these are the eigenvalues. Just you have to substitute the eigenvalues here, then simplify. Okay. So A cube eigenvalues are there, A square eigenvalues are there, eigenvalues of A is nothing but this one, and identity matrix eigenvalues are this one. Okay. So just substitute all the eigenvalues here, then simplify, you will get the answer for the eigenvalues of this polynomial is 4, 34, 110. Okay. Clear? So remaining problems we'll discuss tomorrow. Okay, ma?
Okay, ma'am.
Okay.
Yeah, ma'am.
Thank you, ma. Bye bye. Okay, just
Thank
wait,
you,
just
ma'am.
wait. Just wait, just wait. Don't leave. Naveen?
Ma'am, I'll send you the attendance. I wrote it down, ma'am. I'll send it to you in chart.
Okay, మరి వాళ్ళు ఒకవేళ present అయితే ఇలా once check.
Present
Then
ma'am
send.
వీళ్ళందరూ.
Okay,
Oh, 66, 69,
66. Okay.
69, 83, 84, 88.
ఎవరైనా
92.
ప్రెసెంట్ ఉంటే చెప్పండి అమ్మా.
84 present.
84 అమ్మా, స్ట్రైక్ ఆఫ్ చేయి.
Okay, ma'am. 88, 92, B5, B7, C3, C8.
Ma'am B5 నేను.
ప్రెసెంటా?
Okay, B5.
ఓకే.
Okay,
అంతే కదా? ఓకే అమ్మా, దెన్ సెండ్ ఇట్. థ్యాంక్ యూ అమ్మా. బై.